Hi everyone! In this video you'll learn how to create a realistic ice shader with a parallax effect in Blender. At the same time, the geometry itself will not undergo any changes. The aim of this video is to ensure that you do more than just repeat what I do, but also had an understanding of the principles, how it works, where it comes from, and what results can be achieved. Experimenting with these principles, I'll try to explain to you in accessible language how such an effect is achieved, why we can achieve it with notes. How can this be used? And how is this method better than others? Let's talk about its pros and cons. And we'll try to understand how the world of computer graphics works. If you are new to the world of three-dimensional graphics or already know something and want to deepen your skills in working with materials in Blender, this lesson is for you. I'll show you step by step how to leverage the power of procedural textures and nodes to create an ice effect that can be applied in various projects, from static images to animation. But note that this effect is quite demanding on the hardware, so you won't be able to apply it in any tough situations without having a powerful computer. Before starting, make sure you have the latest version of Blender 4.0 installed, and that you're somewhat familiar with this program. For instance, made a donut following the iconic video. In this lesson, we'll start with a simple scene. Step by step, we'll go from creating a shader's foundation to achieving a realistic result. We'll try to understand how and why this happens, so that you can not only understand but also replicate what I did in the video. But also, based on this technique, create your own materials with a similar depth effect. I'll also share tips on optimization and variations with you, which will help you adapt this technique for your own creative projects. First of all, let's create our project folder. It's crucial to keep your project clean and organized. Ensure it's structured and clear. I would recommend you create a single projects folder where you will keep all the projects you've made. Next, we create a tutors folder where you will store all your projects made from various tutorials. In the tutors folder, create another folder called Parallax Ice Shader, or any other name that is more convenient and understandable for you. Now let's move to the Blender. So, first, let's set up the Blender. Let's go to Edit Preferences. If you have set the language to Russian, then adjust the setting, after which we move to the left to the Interface section, and below change the language from Russian to English. It's important to do this for your future work with the software and for yourself. It will be significantly easier for you to navigate the software in the future, especially if there are no answers to your questions in Russian. I also changed the resolution scale, so it's easier for you to see what I'm doing on the screen. So if your interface is too big or too small, twist that slider. Next, go to the add-on section and search for Node Wrangler. Check the box next to it. Go to the Cycles Render Devices section and instead of Known, select CUDA. If you have an NVIDIA graphics card without RTX, Optics if you have an NVIDIA graphics card, RTX, Chip if you have an AMD graphics card, and one API if you have an Intel graphics card. This means
the teacher will
scene
speed
rendering in the viewport and overall rendering on the Cycles engine. Also, if your system allows, I'd recommend increasing undo steps to 256 and setting undo memory limit to 0. To have a large number of undo actions in case you made a mistake and need to go back to the previous version. Next, go to the Save and Load section and make sure there is a check mark next to Autosave. You can set the autosave frequency to whatever suits you. The time is specified in minutes. After that, press the Ctrl+S keys or go to the File Save section and save our Blender file. In our project folder, let's call it Put the Parallax Ice Shader in the root of the project folder. I'll periodically remind you that you need to save your progress. Now let's move on to preparing the scene. First, we'll set up color management. This is needed for a better look of our future shader. Moving to the right to the render section, camera icon. expand the color management section, and in the view transform section, we select standard. And you can also see on the screen how the shader will look with different settings of this section. Don't forget to save periodically before important actions or after some time. Press Ctrl+, our project is saved, we can move on. Now let's add an environment map. Go to the World tab, the planet icon. In the Color section, click on the yellow circle and select Environment Texture. Before we add the environment map, let's go to our project folder.
And
We'll create a separate folder for HDRI. Try. There, we'll place the environment map. Now let's obtain this very environment map. We'll take it from the Polyhaven website, enter Polyhaven in the search engine. If you immediately got an HDRI section, click on it. If not, go to the website, hover over Essence at the top right and select HDRI. Next, choose the one you like. Open it, select 1K Evo AXR at the top left, click Download and wait for it to load. Place the downloaded .xr file into the HDRI folder. For convenience, you can rename it to Cloud Iskai 1KDH.xr. Instead of spaces, I recommend using underscores and capitalizing each new word. This is to prevent some programs from throwing an error when opening the file. It's better to get used to proper naming of your files right away, to save time and nerves in the future. Now, under the Color section, select the button. Go to the project folder, hdri.cloud.io, Sky 1000 High Dynamic Range Imaging AXR. Press Open Image to see the results of our actions. By turning on Render Viewport in the top right, we can eliminate the light, leaving only the camera. Maybe set the light strength below 0.7. Press Ctrl, Alt+, numpad 0, to teleport the camera to the same position we are looking at. At the top right, pull out the curtain. In the View tab under the Lock option, select Camera to View. First, we select the camera by clicking on the camera icon to move to the appropriate section. Change the focal length to alter the lens angle. I'll set it to 100 millimeters. Go down to Viewport Display and set the Passport to parameter. And turn it all the way to the right, so that we don't see objects beyond the camera frame boundary. Set up the camera. Now let's make a special window for the camera. We won't work closely with objects, so instead of outliner, I switch to 3D viewport. Set up the viewport to view from the camera to the yo key or the tilde. I turn off all the gadgets and overlays. I messed up the footage, so now I'll show you how to do it, and we'll continue right away. To turn off all the gimbal and other unnecessary stuff, we either expand the viewport window by holding down the left mouse button on the edge, or we press the middle mouse button on the top panel and move the mouse sideways. Click on these two mofos and it's done. And I turn on the render mode by holding down Z. Move the cube left and smooth it using the bevel modifier. Set segments to 4. Right-click on the cube and select Shade Smoothing. Smooth. Let's disable Camera 2 view and create Suzanne, then press Ctrl+2 to immediately apply a smoothing modifier with value 2. Right-click on Susan to shade it subtly. Insert with and without the subtle shade. Let's create a plane and move it to the right. We've finished creating the scene, moving on to the material itself. We change the main window to Shader Editor and remove the timeline by right-clicking on the joint and selecting Join Areas. The window that lights up will remain brighter, while the darker one will be removed. Next, we choose our cube. Rename the material to Ice Shader and for now disable the principled BSDF. We see that the cube has turned black, but not the other objects, so we select the object and assign it a material from above. Repeat this with all objects in the scene. Let's delve into the technology we will use to develop this shader. The method we chose is called RayMarching, RayTracing method. This is an advanced technique in computer graphics used for scene rendering. It's based on the sequential movement of the ray from the viewpoint, accompanied by checking for intersections with seen objects at every stage of its progress. Are you wondering what the heck I just said? Well, let's figure it out. To grasp the essence of the method, let's compare it with ray tracing. In the real world, light rays emanate from a source and scatter in all directions. In computer graphics, accurately reproducing this process would be too costly.
In terms of resources,
many rays might not reach the cameras. Thus, ray tracing uses a reverse approach. Rays are emitted not by the light source, but by a virtual camera. Each pixel in the image corresponds to a ray, directed into the scene and reflected off objects back to the light source, allowing the pixel color to be determined. RayMarching operates on a similar principle, but with one key difference. The path of each ray emitted by the camera is limited by the distance to the nearest object it might collide with. To illustrate, let's look at the spherical constraint method. A sphere is created from the camera that touches the edge of the nearest object, forming a kind of safety zone. The ray advances to the boundary of this sphere. Then a new sphere is created, and the process repeats until the ray reaches the object. How will we apply RayMarching? Imagine each ray of light as an arrow fired from a virtual light source. These arrows move across the scene until they collide with an object. At the moment of contact, the ray of light can be reflected, refracted, or absorbed by the object, depending on its properties. Using this method, we will instruct the arrows on how and when to change direction or disappear, thereby creating a depth effect in our virtual eyes. Using Voronoi texture and noise texture nodes in Blender, we will create a guide for our arrows. This allows us to model the geometry inside our object without real geometry, using a brightness range from 0 to 1. Value 0 here corresponds to no geometry, and value 1 to a conditional boundary or object wall. It's also important to understand the role of signed distance fields, SDF, in this process. Signed distance field serves as an additional instruction for our arrows, providing information about how close or far is each point in space from the object's surface. In a brightness range from 0 to 1, SDF values intuitively show where the surface of an object is. 0 indicates the complete absence of the object, and 1 indicates its full presence. Thus, using SDF, we can guide arrows more precisely and efficiently during RayMarching, creating the desired depth and shape inside the object. This introduces us to RayMarching concept. The essence is that we will limit the depth of our object using logic similar to the logic of spheres, where each sphere symbolizes one step. It allows to avoid massive computational expenses associated with calculating infinite depth. In our case, we will limit the process to just a few steps, for example up to 16, but this number can vary depending on the requirements, relating to the quality and available resources of your computer. Actually, remeshing is used a lot in Blender, for example with metaballs or volumetrics. With the explanation of the concept done, we move on to practice. Right now we'll make a simple base, which we'll modify to create an ice shader. For those who don't know how to use the shader editor, here's a brief overview. Select nodes with the left mouse button. To drag the selected node, press G and move the mouse. When the node reaches the point you want, press the left mouse button to stop moving it. You can create a node by pressing Shift+A and start typing the name or search in the drop-down menu. To reset values in a node, you can select it and press backspace. All values will revert to their original state. To duplicate a node, press Shift and D together and move the node. The principle is the same as with regular dragging. You can also see pictures above my nodes. That's the Node Preview add-on. I'll talk about it at the end of the video. The water part has come to an end. The rest we will learn in practice. We'll start creating the base by placing texture, coordinate, and geometry nodes. The geometry node gives us access to various geometric data about an object's surface, including the incoming vector. The vector incoming in the geometry node is the direction from which the ray came. In the context of the shader, this ray represents the direction from a point on the object's surface back to the camera or to the light source. Essentially, incoming shows the path that light or a gaze will travel from the observer to a point on the object. What we discussed when we touched on the topic of ray tracing work. From the texture coordinate node, we need the object vector, which provides information about the object's point positions in its own coordinate system. This vector is used to correctly display textures on an object, considering its shape and orientation in space. Let's make a node, a simple SDF node. Take the noise texture, attach the texture coordinate object vector to it. See what happens before and after the vector is connected. Let's add a Voronoi texture node. Immediately select the distance to edge method and add mix color. In A, we insert the result of the noise texture node, and in B, the result of the texture coordinate object node. Thus, we've created a mixer that blends the standard object vector with the distorted object vector passed through a noise texture. Now, by moving the slider in the factor, we see what happens with the Voronoi texture. Let's combine all this with the Ctrl plus G key combination and call the resulting node SDF, changing the SDF node's input and output names to texture coordinate and distance. However, since the node's output in Voronoi is exactly what we need it to be, we leave it as is.
Dubbed right away.
We'll amplify the SDF node and set it aside for now. Let's create two vector math nodes.
Unscale
Second
track.
lieutenant. And connect distance to the scale input and to the vector connect incoming. Connect from scale to the bottom vector subtract and lead object to the top vector. It's not quite clear yet why we did this,
But the effect will be visible.
when adding additional steps, let's figure out what we did here, where and why we connected it. We connect scale to the lower vector subtract to account for changes made to the texture or vector caused by scaling. In our case, to simulate light distortion inside ice. So we just insert a texture, and with each subsequent step, we'll be moving deeper into this texture. The vector incoming is connected to another subtract input. This allows for considering the direction of the beam that reached a point on the surface of an object, and accordingly modify the texture or vector field depending on that direction. In simple terms, when we rotate the camera around the object, we'll see that very parallax effect and what's inside the object. Connecting object to the top vector. Subtract can be used for additional control over the original position of the object's points. Affects the final effect of the shader. If it's simpler, I have no idea how to describe it. Hope it's clear and you haven't fallen asleep yet. Using these two nodes together allows you to create a complex effect of light interacting with the surface, modeling how light bends and scatters as it passes through transparent or translucent materials, such as, now that we're all done, let's put it in another group and call it stem, or a step. Change the name of the input and output. Instead of vector for input, write incoming, and for output, say step. To make it clear, we've kind of already taken a step. Also, we stretch the incoming to the node's output to get a through vector, incoming unchanged. We name the node step and make it tiny. I'll disable the preview for nodes for easier work. Now duplicate our step node and place it right under the previous one, then connect them and repeat until there are 8 or 16. Now we can see the result by clicking Ctrl plus Shift plus LMB on the very last node. Let's do it for now. A more pleasant appearance, namely adding a mathematical vector node for distance, so that the distant parts are colored white. Close to black. Now let's limit the depth of our shader by going to the SDF node. And at the very end, let's add two math nodes with subtract and multiply methods. Be sure to check the clamp option in subtract. We put a clamp to avoid output values below 0. This is necessary to prevent various artifacts in our shader. Adjust the value to an acceptable look and feel free to experiment. For example, in SDF, connect only the noise texture to see a nebula or something similar. Return it to its original state and add a hue saturation value node after distance with the value set to 3. Let's slightly adjust the value in the SDF node. It's time to complicate our SDF node to make it more like the final result. To do that, we go into the SDF node. After the Voronoi texture, we add here saturation value and color ramp, and set the following values. Don't forget to replace ice with a shader linear in color ramp. Also, we change values on the other nodes. All these numbers were selected through trial and error, so don't be afraid to experiment. You might get a better outcome. But if you look closer, something's missing. The ice is too pristine, such rarely occurs. So let's add some snow and internal fractures. Create a mass grave texture and connect it to a color ramp. Here, you can experiment or set values obtained by me through experimentation. Now we need to blend this snow with our cracks. To do that, before the subtract node, we add a mix color node and connect it as follows. We activate snow in the factor. So the resulting texture will be a mask, and put black in the B value. Let's finally paint our ice to see more clearly what we're missing. To do this, we exit the SDF node by pressing Tab, and after hue saturation value, we add a color ramp node and set the following colors. To add color, press Keytrail plus left mouse button on the color bar. 1 pose H0, hex HBFBFBF, 2 pose H0, 2 loops. XH3 BUFD6, 3 positions, H0709, XH490858A0, 4 positions, H1, XH24 PPP sensor. I also adjusted the values to achieve a more acceptable appearance. Don't hesitate to play around with the values yourself for achieving the best result. Now let's add the ability to scale our ice shader and also discuss one important detail. The thing is, now the shader is generated based on the object's texture coordinates, which isn't always convenient. Because if we take a plane and stretch it, then our shader will increase along with this plane. And also on complex objects, we won't have the parallax effect working correctly, which isn't good. To avoid these, we can do the following. Find all the lines of the object vector and with Shift held down, right-click along this bundle. The node we've created can easily be switched from texture coordinate object to geometry position. In this way, we are relying not on the texture coordinates of the object, but on the space in our 3D world. Now we need to add the ability to scale our shader. To do this, we add a vector math node with functional values. Scale and set the value, for example, 0.560. Done with that. Now let's improve our shader, specifically by adding more snow cracks, but in a way that they don't affect what's inside the ice. To do this, let's go into the SDF node and copy everything except the subtract and multiply nodes. Press Ctrl plus C and exit the SDF. Paste it into the roots of our shader and immediately wrap it in a group. Connect the inputs and outputs, call them vector, coordinate, and snow. And let's slightly change the contents of our node. Specifically switch color mix to difference. And add a math node with a function. This way, divine. Repeat all the steps I did on the screen. I have reminded you repeatedly and will remind you once more. Do not be afraid to experiment with values and nodes. With the knowledge you have gained from what you have already watched, you can create not just such parallax ice, not only a huge amount of all sorts of stuff. I want you to understand that experimenting and trying something new is important in creating shaders. It will be good if you set yourself a goal. For instance, like I did with ice. When I learned about this method, the video where I saw it, it only showed how to create a space nebula. Seeing good potential in these and having a strong desire to create shimmering ice, I spent about 2 to 3 days getting it to the look we're aiming for now. We finished with the lyrical digression. There's just a little bit left. Exit the newly created group, name it Snow, and connect our vector from the node. Let's make everything roughly nice. Now let's add our snow to our cracks. To do this, after the color ramp, we add a mix color node and connect the snow below. Let's slightly brighten our ice. To do this, duplicate the hue saturation value node and insert it after the mix color node. Almost ready. Now, for a realistic look, let's add the principled SDF node with the following settings. The final touch is the normal map. Let's do it now. For that, we conduct mix color from our floating SDF. Just below, we create a mass grave and wave texture with the following parameters. Connect with mix color and factor, set 00T050, then assemble such a structure. Too lazy to describe, it's all visible in the video. In the end, we get such an interesting ice effect, with some flaws and distortions, but they can be chalked up to light refraction through the ice thickness, or just say, I'm an artist. That's how I see it. That's all. Hope this lesson was helpful to you. You can find all the project source files in my booth. There you'll also find a small bonus for more convenient work with nodes in Blender, as well as a text version of this lesson. It will be launched there. You can discuss this lesson in the comments below or check out our Telegram chat cgskvor. If you encounter any error, review the video carefully again. Check if you've entered all values and completed all the steps. Also, at the bottom of the command line, the essence of the error is always written. Try inserting it into Google. Find a solution. I hope everything works out for you and wish you luck in all your endeavors. Enjoy this masterpiece that made me depressed and has had me crying into my pillow for 30 years before sleep.
Я хочу снять новое видео, но ненавижу свое отражение. Ты мне сказала, что я некрасивая, я тебе поверила. Давай называть вещи своим именем. Я неуклюжая, площавая, толстая. Не удивляйся, это все твои слова. Я их запомнила. Мальчик-абьюзер, ты меня поюзил, смял мое сердце. Ай-яй-яй. Пока-пока.